Hello and welcome to 8.5 using the distributive property. This is Mr. Klein, your favorite math teacher of this year. Our main goals for this section is we're going to use our distributive property to factor polynomials. And then we're also going to solve some equations of the form ax squared plus bx equals 0. You have your common core standards listed there, which really doesn't mean a whole lot to you, but it means the world to me. All right, so what in the world does it mean to factor? So anytime you have the distributive property, distributive means, if you had something that we learned back at the beginning of chapter 8, where if we had like a 2 times x plus 2, the distributive property means that we would just multiply 2 times 2 and get a 2x, and then we would take 2 times 2 and get a 4, so you get 2x plus 4. Well, what we're going to be doing today is we're actually going to be starting with what we have on the right, and we're actually going to be moving from this direction back over here. So you're actually going to be doing the opposite of what we did the first half of chapter 8. So anytime you can use the distributive property to work backwards and express a polynomial as a monomial factor and a polynomial factor. Remember, monomial means one term, polynomial means two. This is called factoring. All right, so factoring actually is just a fancy word for dividing. So what we have to do when we look at example 1 is we're going to use the distributive property to factor each polynomial. So factoring. If factoring really means dividing, then when we divide, you have to figure out what is in common. So if we look at 15x plus 25x squared, we need to find some number that is in common between 15 and 25. So if you think about the factors of 15, so if you list out your factors of 15, you have 1 times 15, 3 times 5. If you list out your factors of 25, then you would have 1 times a 25 and 5 times 5. So if you look at the two lists for each of these groups, you would find out what's the largest number they have in common. So I have a 15, no 15 in common. I have a 25, no 25 in common. Here I have a 5. I also have a 5. In fact, I have two 5s, but you only want to pair up one. So what we're going to do is we're going to take this 5 and we are actually going to divide each of these by 5. Now the next thing we're going to do is we're going to look at our x values, or at our variables. We have an x here and we have an x squared. So if we have an x and we have an x squared, then the variable we can take out here, they each have one x in common. So basically, this 5x, this is what we like to call our GCF, our greatest common factor. We're going to write that 5x out front, and then what we're going to do is we're going to divide each of these terms by a 5x. So if we take 15 divided by 5, that will give us a 3. And if we take x divided by x, well, those just cancel out, so we have just a 3. So then we're going to bring down our plus sign, so we drop down the plus, and we take 25 divided by 5, which would give us a 5. And then if we take x squared divided by x, well, this 1x on the bottom cancels with 1 on top, you have 1 left over. This is your factored form. This would be your final solution of a factored problem. So now you can always double check your work just by make sure by what we did back in at the beginning of the chapter. You don't have to show this work, but it might help you. If you take a 5x times a 3, that gives you a 15x. If you take a 5x times a 5x, that's going to give you a 25x squared. Notice this is exactly what we originally started with. So if this is what you originally started with, then this will help you with your fun factoring here. So that's how you finish up part A. So if we look at part B, we're going to do the same thing over here on part B. We're going to look at all of our numbers. So we have a 12, 24, and a 30. So this really helps if you know your factors of numbers. Like means if you can write out factor trees. So what I'm going to do is I'm going to write out your factors of 12. So all your factors of 12, you have a 1 times a 12, 2 times 6, 3 times 4. We're going to try to find out if 24 and 30 have any of these numbers in common. So let's do 24. This is probably be a little bit longer list. So you have 1 and 24, 2 and 12, 3 and 8, 4 and 6. If you look at just these numbers, notice they each have a 12 in common. That'd be great, but we have a third number which we also have to make sure has something in common. This would be 1 and 30, 2 and 15, 3 and 10, 5 and 6. So unfortunately we don't have a 12 over here because 12 and 24 had something in common, but what we're going to do is we're going to look for another number that's in common. So what I always do is start with your smallest number, and since the 12 doesn't work, then that means try a 6. So you look for a 6. So we have a 6 here in 12, we have a 6 here in 24, we have a 6. Perfect. That is your next, that is your largest number that all three of those terms have in common. So we are going to take out a 6. So I'm going to put a 6 underneath here just to show we're going to do some division. Next thing you do is you look at your x's. So I have 1x here, and I have x squared here. The most you have in common is just 1x. So we can only take out an x from each of those three terms. Then you look at your y's. I have a y squared, and y to the fourth. The most amount of y's we have in common is also just 1. So we have 1y here. We can take out a y.
Mrs. Blackburn, call
take out a
extension 2304, please. Mrs. Blackburn, call 2304.
So we're going to take out 6xy. And left over in parentheses is going to be whatever we get when we simplify each of these fractions, which we did back in chapter 7 and also in chapter 8. So we take 12 divided by 6, that gives us a 2. If we take x divided by x, well, those cancel. Y divided by y, those cancel, so you have just a 2. Bring down the plus sign. 24 divided by 6 gives us a 4. So those numbers are gone. X divided by x, whoosh, see ya. And then y squared divided by y gives us just a y. Bring down your minus. 30 divided by 6 is 5. Get rid of the numbers. X squared over x is an x. Y to the fourth over y is a y to the third. So this is your fully factored polynomial. We took out a greatest common factor, which was 6xy, and divided each of those three terms by what we took out. Notice inside the parentheses, all three of these terms do not have something in common still. That is how you're going to use your distributive property to factor.